Okay, good afternoon, everybody. So, today we are going to start with the today we are going to start with the next module, that is the memory system. Okay, so in the previous modules, whatever we have studied, if you are having any doubt in that, you can ask me anytime. So, today we will be studying about the third module, which is about the memory system. So in the memory system means basically we are going to study how the circuits are constructed, how we are going to transfer the data using these circuits, means the memory. Okay, how the memory transfer is taking place. So the performance of a system always depends upon the how data transfer is happening between the different components of the system. So here now we are going to study about a few of them, starting with the basic concepts. So how do you define a memory here? Means how can you say what is the size of the memory? The size of the memory can be defined by how many addresses are generated in that particular system. Suppose we are taking a 16-bit computer, so 2 raised to 16 addresses can be generated. So 2 raised to 16 means here you can see it is 64 bits. Okay, it is 64k memory locations can be generated. So this is the total number of total memory size. 64k is the total memory size of that computer. If I take 32-bit computer, so 2 raised to 32, that is nothing but the 4 GB data. Okay, that much of data can be stored into that system. So basically how is the memory, what is the size of the memory depends upon how many address locations can be generated. Uh, how many address locations can be generated by the system defines the size of the memory. So in the basic concepts we have already studied about this diagram here. So what we are going to do here is just we are going to refresh the whatever we have studied. Now what happens, how when we are going to transfer the read or write the data, these two registers are involved into it, which is that MAR and MDR register. What is MAR register? What is the MAR register storing into it? Yeah, tell me, what is the MAR register storing into it? Am I audible, students? Am I audible? You can drop a message in the chat box there. Hello. Am I audible?
Yes, ma'am.
Okay, okay. Okay, now tell me what is MAR then? Yes, tell me what is MAR. MAR is nothing but memory address register. This we have studied in the first module itself. So whenever we want to transfer the data, let us take example of the read operation now. What happens in the read operation? First, this processor, whatever processor is there, this processor will give the address from where the data is to be read. That address is stored in this MAR register. So once the MAR register is storing the address, that address will be given to the memory here. Okay, that MAR register, whatever address it is having, that address will be given to the MAR register. Then the memory, it will take the address from this MAR, and from that particular address it will take the data, and that data is stored into this MDR. That data is stored into this MDR by this memory, and then it will generate the MFC signal. What is this MFC? MFC is nothing but the memory function control. Okay, so what does this mean? Means that memory function control means it is telling that after the data is got and it is stored into the MDR register, this is generating a signal to the processor. Once this signal is active, the processor will understand that the data is already stored in this MDR register. So that data can be again then used by uh, uh, the processor. It will read the data from MDR and then it will do the processing. This is how the read operation takes place. So now here we are having a k bit address bus. Here we are having the k bit address bus, means for transferring the address from the processor to memory or from the memory to processor, k bits of address buses we are having and n bits of data lines will be having. And here we are having the different control lines, that is MFC read write. See, now we were doing read operation, so it was set to 1. If it is a write operation, then it will be set to 0. So like this, the different transactions of data will take place from the processor to the memory. This is what we have studied. Now I am telling you the memory and processor. So here in memory also data is organized in some fashion, and in processor also data is organized into some particular method. So how it is organized, what types of material is used into it, that is what we are going to study in the next topics. So we have seen here about the read write register, MAR register, MFC signal we have studied about. Then now we are going to the next one. Next few concepts which are required, we have to understand about the memory access time. What is this memory access time? Memory access time is, see, whenever the time between the read and the MFC signal. Okay, what does it mean? Time between the read means what? Initiation, see, when the processor will start the operation, from that time until this MFC signal is generated. When is the MFC signal generated? When the data is kept in the MDR register. When the data is kept in the MDR register, it means that data is fetched. So starting from the initiation till fetching the data, whatever the time it requires, that is called as the memory access time. The memory access time, it is the time between the read operation and the MFC signal till the complete data is stored into the memory data register. The time between those is called as the memory access time. Next is the memory cycle time. Memory cycle time means, see, now we have completed one read operation, next we want to do another read operation, after that another. So the time between two operations, two complete operations, that is called as the memory cycle time. What is memory cycle time? Memory cycle time means it is the time required between the initiation of two successive memory operations. Two successive memory operation. Now I have completed in the previous example. Once I have completed the read operation, to start the next operation, to hello students, are you there? Students, are you there?
Yes, ma'am.
Okay, I'm not hearing anything from your side, that is why I am confused whether are you there or not. Okay, that is called as the memory cycle time. Memory cycle time means it is the time between two successive memory operation. One may be read, another may be write. So the time between those, starting ending of one operation and starting of another operation, so the time between these two operation is called as the memory cycle time. So now next we'll be studying about something called as a random access memory, that is nothing but the RAM. What is random access memory? It is a static memory. Yes, tell me anything, any properties do you know about this RAM? Do you know any properties about this RAM? Yes, tell me. Do you know any of the properties? Do you know any properties of this RAM?
Smaller in size.
It is a smaller in size and it is also called as a volatile memory. What do you mean by volatile memory? Static or volatile memory? It means that it retains the data only till the power is supplied to it. So now this has happened many times for you, is it not? Whenever you are working on a computer and you are using some this one, you are using some word, you can say Microsoft Word, and you are typing something, suddenly current goes off, the system is turned on off, and you have not stored the whatever you have typed, that will be lost. This is called as a static memory. So whenever you are saving it, then only it will be stored in the secondary memory. Whatever currently you are typing, everything will be in the RAM only. So a RAM will lose the data as soon as the power is cut off. So this is called as a random access memory. So with this we can do any read, write operations, anything we can do. So what we are going to means how the data transfer is taken place in this RAM, that will be studying in the next topic here. And the performance of the system depends upon the type of RAM we are using. It should be very fast. Okay, this is the fastest access memory, and data is all whatever you are currently using, that will be stored in the RAM itself, so that you can increase the performance of the system. Another method of increasing the performance is by using this cache memory. So what is this cache memory? Cache memory means it is a small memory which is between the processor and the main memory. Okay, between the processor and the main memory you are having a cache memory. What is this cache memory? It is containing the data which is frequently used. So it is a temporary data which is containing the frequently used data into it. So to reduce this access time, what do you mean by access time? The time to get the data. To reduce the access time, we are using this cache memory. So if we are taking less time to get the data, then we are executing the whatever task we are having at the high speed. That is why we are using this cache memory. Another method here we are going to use here is virtual memory. So what is this virtual memory? Virtual means false, is it not? So virtual memory, suppose the memory of a computer is fixed. Okay, the memory of a computer is fixed, but sometimes what happens, whatever program you want to execute, that is more than the size of your memory, I mean RAM. Okay, that is more than the size of your main memory, but still you want to execute that big program. So this is possible with the help of this virtual memory. How it is possible is, only the part of the program which you want to execute, only that is brought, not the complete program. So every time what happens in a program, there will be many parts where which will not be executed at any time, which will not be executed at all. For example, let us consider a C program and if else statement. So if the if condition is true, then always the first part will be executed, else part will be skipped, is it not? So this else part is if the condition is always true, then this else part is not executed at all, is it not? So when it is not executed at all, why to bring that block of code into the memory? So such cases can be handled using this virtual memory. So what does virtual memory tell you? Virtual memory gives more than the size of your physical memory. virtual memory gives the more memory size than your physical memory by loading only those part of the program which are required. So this is another method. One is cache memory. Use to reduce this memory access time, we can use the cache memory. To increase the size of the memory virtually, we can use this virtual memory concepts. Just you are having the introduction of this one, not in detail. Next, we are going to study about the semiconductor RAM memories. So all these memories are made up of a semiconductor material. That is why they are called as semiconductor RAM memories. So initially when the RAM was developed, that time it was very costly. Okay, that time it was very costly because it was involving many of the transistors, capacitors, all those things into it. But with the rapid growth of the technology in VLSI, that is very large scale integration technology, the cost of the semiconductor memories have been dropped. So we are going to get a RAM almost at 1800 rupees now. Okay, like for example 512 MB of RAM. This is the lowest I'm telling. Okay, so we are going to get something around 1500 to 1800 rupees. So that is comparatively cheap when we are comparing it with the other memory components. So like this, with the development of this VLSI, the semiconductor memories rate has been dramatically reduced. So in that we will study now the first organization, internal organization of the memory chips. So how, see, whenever we are storing the data into the memory, that data is stored in the memory in terms of cells. Memory is organized in terms of cell. Each cell is storing only one bit of data into it. Okay, so each cell is storing only one bit of data. This is the so this is the block diagram which will tell you. See, I am telling, see, this block B0 to B7. So B0, B1, B2, B3, B4, B5, B6 and B7. So 8 bits of data is stored here. These are small cells. Okay, this is a memory diagram complete. This is a memory diagram, and each cell here is storing one bit of data. B0 bit means one bit. Bit means what? It is either 0 or 1, a single digit, that is called as a bit. So that bit of data is stored in this cells. Okay, like this, and 8 bits together is making one word. What is a word? Word is, what is a word length? We have studied in the first module. Anybody can answer? What is a word? What is a word length, or what is a word? Word means it is a multiple of bytes, or the word tells you how much amount of data can be transferred at one time. If the word length is 8 bits, then 8 bits of data can be transferred at a single time. Okay, though we have studied the example wherein we have taken a 32-bit computer. So what is a 32-bit computer? What is the word length? How many bits, sorry, how many bytes are present in that 32 bits? How many bytes? How many bytes are present in 32 bits?
4 byte, ma'am.
Yes, 4 bytes. So the word length is 4 there. Like that. Here the word length is how much? It is only 8 bits, means 1 byte. 1 byte of data can be transferred at the same time here. So each cell here is organized in such a way that it is storing only 1 bit of data. For that we are having two lines. One is the original and its complement. You can see B0, B0 dash, B1, B1 dash, B7, B7 dash. So like this we are having a complement of each one. So we require 4 bits for generating the address. Here 8 bits are connected to a single word line, W0, W1, W2, W3, like that, W15. So from 0 to 15. So it is 16 words are present. Each word is having 8 bits. Okay, each row, one row means one word, second row is second word, third row, like this. Each row is indicating a single word. Each column is indicating the single bit of that particular word, and each of them are connected to the original bit and its complement. And we are getting the output as only us 8 bits is generated. You can see at the bottom here. So data input and output line, here you can see B0 to B7. So this is the output. I'll be explaining here how it is happening. So like this, the organization, see here you can see the memory cells. These are the memory cells of the whatever data is present. So this complete diagram is collectively called as 15 into 8, sorry, 16 into 8, 16 words into 8 bits. Each bit is having each word is having 8 bits of data. How it is working, let us see now here. So the data is present in each of these bits here. In each of these cells data is present. Then we are specifying the address here, that A0 to A3. This will we are giving the address. Processor gives the address here. That address is decoded by this address decoder block. Depending upon that address, any one of the row is selected. So now suppose here we are having after decoding we will be getting W1 as the address. So this W1 row only is selected. Only this W1 row is selected. Other rows are not selected. So when this W1 row is selected, you can see here this cell is connected to the left side and the right side. So whatever bit is present in this cell, that is given as the output for B7. What is present in this cell, that is given as the output for the B1. Here output is given for B0. Each cell of that row output is generated as a on this output line, data output lines. So how read operation and write operation is done, that is what I have told now. When the address is generated, read operation, let us take the example of read operation. So whenever the address is given by the processor here, that address is decoded by this address decoder, and this particular row is select example, okay, this particular row is selected. So after selecting this row, it was a read operation, is it not? So when it is a read operation, what is the input given here in read, right? So read means it will be a value 1, it will be a value 1 here. Whatever input signal we are getting, no, that is given as 1. First input signal is a read or write signal. I am reading means it will be a 1. Then CS bit means it is a chip select bit. Chip select means which chip to select among all these. There are many chips here. How many chips are there? 16 into 8 chips are there. Out of these, which chip to select? Depending on the address decoder, that input signal is given for this one. Next, for each of the columns, here we are having sense or write circuit. What do you mean by sense? Sense means it is used for reading. Write means obviously it is self-explanatory. Whatever data we want to write, that time this write circuitry will be activated. Sense means it is reading, helps in reading the data of these cells. Write means this circuit helps to write the data into these cells. So now we have taken the example of reading, is it not? So the address is decoded and here read signal is given, and this for example W1 row is selected. When this W1 row is selected, with the help of this CS signal, the cells of only these W1 row will be given as the output as a 8 bit. So using this sense, now sense circuit will work. Sense means it helps in reading. So this sense circuit will work and it will read the data which is present in this W1 row and give the output here from B0 to B7. So this B0 to B7 data output is then given to the processor for doing. What happens for write data? What happens for writing? When I want to write the data, address is given here again. So when the address is given, it is decoded. Suppose again the W0. Now the address decoded, I want to write the data at W0. means I want to store in this first row data. Whatever data I want to store in this first row, I am giving here only as input. I am giving the input at here only, B0. When I will read the data, output I am getting here in the B0 to B7. But when I want to write, the time the processor itself gives the data from B0 to B7 here. Now you can see here it is bidirectional sense and write circuit. We are having the bidirectional here. So what bidirectional means? When we are doing read operation, the output is given by this block diagram to as the output here. But when I want to read, that time, so see here like this, the signal is going to the circuit and also coming from the circuit. It is bidirectional. Okay, so when I want to write the data, the whatever data is there, that is given on this B0 to B7 to this block diagram. When I want to read, what happens? From the data from these rows is coming out here by itself. Okay, so like this read and write operation will be happening for this semiconductor cells. So these are all static. Static means they are losing the power, where they are losing the data when the power is turned off. Then let us see the organization of each of the cells here. Okay, each of the cells, how it is organized before that. Okay, so before that, so this is just only how many words are there in this W0 to W15. So 16 words are there into it. Okay, there are 16 words and 8 bits. Suppose we want to have a larger organization, like for example here we are having a larger organization. So what larger organization we are having? It is of how much? 1k, 1024. It is 128 into 8. 128 words are there, each are having 8 bits. 128. Now here how many words were there? 16 words were there. Is it not? 16 words were there. Here we will be having 128 words. So for 128 words, how the organization is done? See, for 128 words to generate the address, we are requiring 10 bits. Here we required only 4 bits for generating the address. But here we are requiring 10 bits for generating the address. 5 bits for rows, 5 bits for columns. So when same procedure is followed, same, whatever these cells are given here, no? This is the expanded version of the diagram, but these cells are compressed and they are placed here. Same thing, working is same thing. 5 bits row address, 5 bits column address is generated. We are having the decoder for both rows and columns. For rows and columns, both decoder is there, the data is selected, and we are getting the output here at the end. Same signals we are having here. Sense and write circuitry, read, write. Only one thing extra we are having a multiplexer and demultiplexer here. So why we are having this multiplexer and demultiplexer is because the data bits generated are large here. What is this multiplexer doing? Multiplexer means many to one. Okay, it will generate the many to one signals. Is it not? You are giving many inputs, but only one output you are going to get. So that is multiplexing. What is demultiplexing? Opposite of that. You are giving only one input and getting many outputs. That is demultiplexing. Okay, so now here how this is organized? In the larger format of that we have seen here. Address is decoded, then the word, which word is selected, out of that according to the sense and write circuitry, the data is read or it is written, and then we are going to get the output. So this is what happens here. Generally in the exam they will ask only this block diagram. Okay, organization of bit cells in a memory chip. So this is what they are going to ask you. So if at all they ask you, just you can explain this diagram in the larger scale, how the data is read and written. This can be drawn. Next we are going to study about the static memories here. In the static, I told you what is static means. Static memory, it is storing the data only till the power is given to it. Is it not? How it is working? Now we have seen the cells here. I told you these are the cells. So what is the organization of this cell, how this individual cell is working, so that we are going to see in the next diagram here. So for this we are having the two inverters here, these two inverters, which type of gates these are? Not or, is it not? They are called as the inverters. These inverters are connected to each other in this manner, and they form a latch. Latch means it is also used for retaining the data. Suppose in that cell 0 is stored, that 0 should be retained until the power goes off. This is a static cell, is it not? When the power goes off, the cell will lose the data, that is fixed. But till the power will go off, that particular cell should retain that value 0, or that particular cell should retain a value 1. How it is going to retain? With the help of this organization here. So here two inverters are cross connected. See, output of this one is given here as input, then output of the second inverter is given as an input to this first one. So they are connected in an inverted fashion to form a latch here. Latch is used as a switch to store the data. To store or to retain the data, latch will be used. Plus we are having two transistors here. We are having the two transistors T1 and T2. These T1 and T2 are also acting as a switch. So now we have seen B naught, B naught, and B dash we have seen in the previous example. Each of the bit was having its original value and its complement value, original and complement, is it not? So in the same manner, so how one cell is organized, that is seen here. So these these transistors are connected to the word line. We have seen this W1, W2, W0, W1, these are the word lines. That is how we are connected here to the word line. So when these switches, these transistors are acting like switches. Okay, these transistors are acting like switches. When the switches are left open, when the switches are left open, the data which is stored in this cell is retained. When the switches are left open, see now they are open here. So these switches are open, you can see the gap between them, is it not? So these switches are open. So when the switch is open, this T1 and T2, when they are open, the data which is stored into it, the bit, if it is 0 or 1, that bit will be retained. When these switches will be closed, when the switches will be closed means the word line is active. Active means some voltage is applied to it. When some voltage is applied to this word line, it will close this switch. When the switch is closed, that time the data will be lost. Okay, when the switch is open means this word line will be connected to ground. When the switch is open, okay, please make a note of this one. When these two transistors are left open means when the word line is connected to ground, that time the data which is stored into this circuit will be retained. Okay, it will be retained. So like this, the data in each of the cell is working. Each cell organization is this type. So B and B naught. So next we are going to, this is the organization. What I told you, two inverters are cross connected to form a latch. The latch is connected to 2 bit lines by transistors T1 and T2. These transistors are acting like switches. Okay, when the switch can be opened or closed with the help of this word line. So when the word line is at the ground level means the transistors are turned off, means the transistors are kept open. When the transistors are open, that time the latch retains its state, means the latch will store the data as it is. Okay, example they have taken here. Let us assume the cell is in the state 1. So how it is in the 1, that we will see in the read and write operation now. So suppose we want to read the data, how we are going to read the data? The word line is activated and it closes the switch here. The word line is activated means some voltage is passed to this word line, and this switch T1 and T2 will be closed, means they will close. Now it is kept open, no, it will be closed. So when it will be closed, that time you can read the value of this b and b naught. Okay, so if the value of b is high and b dash will be low, that time we are considering the bit present into this is 1. Okay, what it is saying, see here, if the cell is in state 1, when it is said to be in the state 1, when the bit on the bit line b is high. So when we are closing these two transistors, if this b is high, obviously b dash will be low. So when b is high, b dash is low, that time the value of this is considered as 1. And if it is opposite, suppose if b is low and b dash is high, that time the value of this cell is considered as 0. So this is how we are going to read the value of b and b naught. How do we go to the right operation? Whatever we want to write, that value we are giving it to b and b dash. We will close the switch and voltage is applied, and the value of b and b naught will be stored here into the circuit. Okay, similar thing, right operation, the state of the cell is set by placing the appropriate value on b and its complement b dash. Whatever you want to give the value of that cell, that you have to first place on b and b naught, the b and b dash. Then you are going to activate the word line. Activate the word line means you are going to apply some voltage, and then you are going to store the value of b, this and b dash. So this is how we are doing the read and write operation for this static RAM. Okay, so in the static RAM we are using the two inverters crossly connected to form a latch. This latch is used to store or to retain the value which is present into that particular cell, and this latch is connected to the bits b and b dash by using the two transistors T1 and T2. These transistors T1 and T2, they are acting like switches. So when this switch is kept open, means when the word line is at the ground level, that time whatever bit value is present in this circuit will be stored or retained. Suppose you want to read the value, that time you are going to activate this word line, means apply the voltage. When you are applying the voltage, this transistor switches will be closed, and then you will get the value on b and b dash. So if the state of this circuit is 1, then the value of b will be high, b naught will be low. Suppose if the value of this circuit is 0, then the value of b will be low and b dash will be high. In this way we are going to read the data from this cell. If you want to write the data, same data what you want to write, that will be first given to b and b dash, then word line will be activated, means the switches will be closed, then the value of b will be stored in x, this b dash will be stored in y. So like this read and write operations will be done. Suppose I hope all of you have understood this one.